Thanks so much.
Thank you. I hope you can hear me. Yes. So good morning. Thanks for having us. Thanks for your attention. Before we introduce ourselves, let me just present you this little beauty of engineering. That is a A350, so one of the most modern aircrafts on the market. Definitely one of the most modern and advanced aircrafts on the Airbus family. It can carry up to 480 passengers to a distance of 18,000 kilometers. So quite a fantastic piece of engineering, I would say. AI is also part of the journey in Airbus. So our research teams, they work more and more on different use cases, not only with regards to the classical, let's say, operational topics, such as quality inspection, or fuel consumption topics, but also more and more onboard and onboard services. So our clients and customers come to us and asking us to develop some solutions to assist the pilots, to assist even the computing of the in-flight data. So, yes. So some words to us. So my name is Henrik Haarmann, and yes, I'm the only one with a tie today. I'm sorry. My little daughter did it for me this morning and supposed to bring me luck, so I would like to keep it. I work in Airbus since over 20 years, mostly in procurement. So I've been heading procurement organizations all across the Airbus divisions and different companies. I'm actually working for the procurement strategy department together with our research and technology teams. So my job is to onboard the latest technologies and everything our research teams need to develop the future aircraft families. Lukas.
Yes, and big welcome from my side as well. My name is Lukas. I'm the founder and CEO of tracebloc, which is a Berlin-based company which I've started 3.5 years ago. Before that, I was in consulting, working on emerging technologies such as machine learning, AI. And over the last 3.5 years, we have built an AI collaboration platform enabling AI partners such as researchers or consultancies or suppliers even to literally send AI models to those data centers of those companies, such as Airbus, where they're able to train and fine-tune those models and create basically vertical models for specific applications without the need to share the data or to have an IP drain at that matter through a fine-tuned model. So that's what we've been working on, and we have a strong focus on AI collaboration, how to enable the AI ecosystem to work closely with large organizations or the public sector.
So the center of this presentation is more related to procurement rather than the AI technology itself. If you just remember or recall the figures around AI, $73 billion worth of products and services around AI. Over 1 million different AI models already on the market or available. 12 billion investment in consulting. And what is really talking to us, especially from procurement, is that 80% of AI and the AI solutions is done with external partners. So we clearly have a big procurement topic here when it comes to onboarding AI into companies, and especially such as big companies at Airbus. So if we deep dive a little bit into the bubbles, so classically what you have a company like Airbus with very specific use cases. As our colleagues before just said it, you don't have an off-the-shelf product that you buy in the market and then it works. So you have to develop a dedicated AI solution for your specific use case. So therefore you need specialists and knowledgeable people who do that. On the other side, you have what some call the AI market. I call it more the AI community, because this community is composed out of various different players. So you have on one side the classical suppliers. Some of them have already AI solutions onboarded in their devices, such as cameras for quality inspection. Or, I mean, if you look at the consumer market, everything that has an on-off button now has an AI on it, more or less. You also have consulting, which was our main market still a couple of years ago. You have startups But you have always also researchers, so universities, students, professors, and mainly universities who also develop very, very qualitatively high-end AI solutions. So the question here was, how do we access this AI community, and how do we address our specific needs in AI to this market? It's not a usual market, so we had to find a solution. And that leads me to the challenges we had to face. Usually when you run a sourcing event in Airbus, and I guess also in most of the bigger companies, you have a very heavy and robust and, let's say, long-running procurement process. You launch an RFI, an RFP, then you start negotiations. You look at the proposals, you have several rounds of negotiations, you do the contracting. Then you start the work, so you set up a project team, you launch a proof of concept, and then after weeks, months, maybe years, you come to the solution, and the solution may work or don't. And that's one of the biggest problems we face with AI, because if the solution works, and we have very much valuable partners who do a fantastic job, no problem. But if you invest a lot of money, a lot of time, and in the end you have a solution that does not work properly, nobody uses it. Your internal customers, who might be the quality inspection team, they won't use it. You have lost a lot of money, and our clients won't talk to you again with regards to any new AI topics. So that's to be avoided. Also, when you launch this classical call for tender, you are more or less tied up with one provider or one company. So in the end, the company who helps you to develop and to work on this project is also mostly providing the AI solution. So again, if it works, fine. If it doesn't, you have wasted a lot of money, a bit of time. And there's the third topic that was most of the times the showstopper, that is all the issues and the danger that is related to your IP, so to your data. So in most of the cases, you have a fantastic project. You want to launch an AI project, but then your data security or your data officer says, there's no way we give our property data or sensitive data to a supplier to onboard him and let him work on our sensitive data. So that was one of the biggest showstoppers when we launched AIs. And this is how Lukas and tracebloc and Airbus came together, because we wanted to address, nevertheless, this sourcing problem for AI. And I'll let Lukas now tell you how we did it.
Sure. So, I mean, what we need to do in general to cross this bridge between the AI partners and the enterprises in general, and the only way actually to assess AI and see what a good model is, a good fine-tuned model is, if you get those models in touch with the proprietary data of those enterprises. So what we needed to do is literally build an IT infrastructure that allows any data scientist from all over the world to really send their model for fine-tuning purposes to those enterprises, provides them somewhat a visibility over the data set, but at the same time gives them feedback about the training process. And that's what our project was mainly about, enabling this kind of infrastructure in Hamburg, where we set up at a data center there our client and allowed data scientists from all over the world to send their proprietary models or their pre-trained models or those open source models with the training plan, weights, files to Hamburg, where they were able to fine-tune those specific models to cross this gap. Because the only way, once again, to benchmark those models is to allow those models to be trained and fine-tuned on the data. So what we did in this specific project, we looked at one specific use case in the domain of autonomous flying, where we wanted to build an object detection model, or let the community build an object detection model to detect runways for later supporting pilots in the landing phase. Gives them some access, some visibility.
It was more a test model, right? It was not a real use case, really. It was just to allow the people to go to access the data and to mature the system.
Exactly, and so we took the data, we took the annotated data set, moved it into a secure environment, because actually the data, the third-party data of the data science communities, needs to be securely put. It's not put into production, and we enabled exactly this facilitation where we orchestrated the training of those teams, sent those models to the data center, and provided the data science community feedback about the training process so that they could iterate and developing, fine-tuning vertical models for that specific use case. And in this process, we benchmarked and compared the performance of those models, really to cross this gap between those two communities and to unlock the proprietary data, which hasn't been done before. And at the top right, you see basically a leaderboard where we scored those models for that specific use case and benchmarked them. So how did it look? So on the one hand side, we had over 80 teams from 23 countries participating. Over 2,500 AI models were sent for training and fine-tuning purposes, and over 200 models were submitted. And you see here those 3 winning teams or individuals. And what's interesting, usually those data scientists have a pretty strong scientific background, usually did research on themselves, published papers about it. And we were able to, and those researchers, we talked to them after the competition. They were really happy about the opportunity to actually train on industry data sets, because usually in the research space, those open source public data sets have been used over and over again, and they're eager to test their technology on data which hasn't been used and is highly relevant for enterprises. So that's what we did. So that was one reason why those data scientists participated. The other one, they were incentivized through a prize pool. So those 3 winning teams were able to gain some financial benefits.
Okay, so that was a fantastic first test, because we could address all of the different problems. So basically what you said, you can even define the price up front, so it runs like a competition. It's even fun to look, because you have the progress of the different teams, then they fine-tune, there's several iterations, and then you introduce new data, and then the model runs again. It's even fun to look at, right? Whereas compared to a normal sourcing process, we have addressed also this data security problem, because instead of sending the data or making data available for somebody who's developing you an AI, we keep the data secret. We have it in a safe place. We tested it in the ZAL, in the Center of Research, so it's even disconnected from the Airbus network, completely safe. And the only exchange that we had with the external was let's say the performance indicators that allows the teams to adjust the models. So that problem was addressed, and the third one was the easiness. To be honest, the whole thing runs on a very easy user interface. You can put your sourcing documents, your competition rules on the user interface. The competitors can register within minutes or seconds even. And the competition runs for, I would say, maybe weeks. We did it in 3-4 weeks, the several iteration rounds, and you have a result after a couple of weeks compared to multiple months in a normal sourcing process. And again, we did a first, let's say, trial test with very, very low competition money. We invested something like 20,000 euros, and it was done. So we were very happy about the results.
Exactly, and 2 more use cases how to leverage this, because we mentioned it, a lot of suppliers are actually embedding AI solutions within their products as well. And to strengthen the collaboration between OEMs and their suppliers, we looked at use cases such as one in the quality inspection, where suppliers who are building the hardware, but at the same time the software as well and those models as well, need to be able to fine-tune those models to increase the performance of those models and increase the value that they're driving for customers such as Airbus. And one of the ideas that we're currently looking into is camera supplier. So they have usually strong data science teams, they know their hardware best, but they lack the access to annotated data sets. So what we can do here is just allow those teams to send their pre-trained models to those data centers once again, where they get in touch with the data, are able to fine-tune them. Those fine-tuned weights always stay at all time on-prem, so there is no IP drain, but still gives them a way to increase the performance of their models and in the end create more value for your organization. So that is one thing that we're currently looking into. And the second thing is, one is close to my heart, is basically, I mean, we have amazing researchers in Europe who are building fantastic new architectures and would like to try them out on real data sets, industry data sets. And so crossing this gap, basically having this knowledge transfer from research into the enterprises often seems tedious and quite long. And with this kind of infrastructure, we would like to encourage researchers to test out their models, because sometimes those models, I mean, we don't even know if new architectures are proven to be viable and performant if we haven't tested them out on enterprise data sets. So we need to enable the researchers to actually access enterprise data, industry data quite easily to innovate and to build architectures which are designed for the industry and support organizations in onboarding the technology and providing transparency on what is actually available or state of the art in the market.
Thank you.
Thank you. Okay, you're welcome. And we still have some time for 1 or 2 questions. If you have some, please come to the microphone. Look. Okay, if this is not the case, so maybe one question from my side, and actually for you. So you had this one project to detect the landing spaces and to support this. Are there some future projects where you do still want to explore AI and make another testing rounds?
Yeah, of course. The aerospace environment is a bit tricky because there's a lot of constraints regarding security, and especially if you onboard technology on an aircraft, there's huge hurdles to pass. But yes, our engineers work on solutions. So this was a very simple, let's say, example, because we needed a use case to be trained on. That was an easy one. So the game, if I may say, was to detect, let's say, landing facilities in bad weather conditions, right? So yeah, you had to make sure that the computer or the AI solutions helps the pilot to detect the right way, runway. But there's many other options. There's currently one use case is being installed, like in a car, where it detects the fatigue of the pilot, for instance, to make sure that the pilot is still awake. But there's also models being trained actually on rerouting the aircraft or finding the best routes to reduce the fuel consumption. And then in the operations, you have multiple use cases. So we had here a little picture of the seats. Mm-hmm. As you know, we buy the seats. It's not something we do ourselves, so we buy them from suppliers. And we receive them in big quantities, and then somebody has to check if the seat is okay, no scratches or wrinkles. So it's a really tough work to do. So it takes almost one journey to do a full aircraft, and the idea was to develop a tunnel with a camera. We use an AI to detect defects on the seats. It could be done in 1 hour. But I mean, open end, right? There's everything you have in the industry applies to us too. In the other.
So still a lot of projects to come in the future, and it's more
absolutely.
Okay.
More related to production for the moment, but also future is also onboarded solutions. Yeah.
Okay. Cool. So
we have one more question.
One question. Yeah, please.
My question is, so the data set you use for training for this competition you have was publicly available, right? And then they just send the models over, and the results were there, and you could see, this model is good, working well, right? So how would you, because you said it's about keeping the data private, what if there's no publicly available data set for training, right? If it's actually data that is very valuable for Airbus, I don't know, on the engine or something like this,
I mean,
it wouldn't work, right?
for this project specifically, we took an open source data set just to make sure that the end-to-end process works. I mean, we're looking into other use cases where the data completely stays safe, and the data scientist gets the EDA about the data set. So the metadata about the data set to get an idea about what kind of model strategies to apply and to iterate, because as a data scientist, you need to have at least some information about the data set. Otherwise, you would be completely randomly using probably state-of-the-art models for that specific use case and hope that something sticks. So you need to have at least some kind of information that work particularly well within that or other competitions as well. And you get model feedback. So you basically get a scorecard about the training, the performance, the loss of the model, so that you get an understanding which direction you should be moving.
And still another question, yeah.
Hi, my name is Laura from Globant. And what I understood is that, like, using the example from Airbus and tracebloc, that Airbus is providing the data, and then tracebloc is providing the access and different models to use on the data. How do you ensure the transfer of the knowledge, especially when you further develop the model you choose in the end?
You mean the handover of the code in the end?
Yeah, handover, and especially when you then further develop the model over the years, for example.
Yeah, we can use different kind of sourcing models. So we have different kind of contracts similar to software. So you can decide whether you want to get the whole ownership, so the complete IP of the code, or if you want to have a longer term relationship with your competitor or supplier, and then make a license. But in this case, we did a full handover of the code.
Okay.
Maintenance of AI is done in-house. So we have our own data scientists, and they work on the on the deviations, et cetera, et cetera.
Thank you.
And those tools, I mean, those models are usually leading into the MLOps tools of those organizations. So there's a handover of model weight files into those MLOps tools, where they'll be once more checked and then provided via API or container to that specific, embedded into that specific solution. So this is really a tool which can be used to identify and collaborate with your partners, identify the best AI models, which then can be used in your MLOps tool and provided to the whole organization.
All right. So once, thank you for your talk, and thanks for having you here.
Thank you very much.